Hey guys, so in this video I'm just going to continue on with the Python Data Science Handbook and continue on the Introduction to Numpy section. But this time looking at computation on Numpy arrays using universal functions, or ufuncs. And this was pretty damn long, but got a lot of useful stuff and it's going to make everything a lot quicker as opposed, like, you'll see actually. So basically starts by saying how NumPy is important. It's like the most important thing that Python like data science, just because it's it provides an easy and flexible interface for optimized computation with using arrays of data. But the key to making computation fast is to use vectorized operations. You can see here. So the key ufuncs, and these can be used to make repeated calculations on array elements much more efficiently. So you actually just see how that works. They work basically a better version of using loops in Python. So let's see. And again, I'm a beginner coder, so that's the point of these videos. It's not going to be quick, like speed coding, like the common person on YouTube does. So yeah, keep that in mind. Let's start by set that equal to x. So we just created the array of 10. So from range 0 to 10, not including 10, and set that equal to 10, x. So the way ufuncs work is that we could use them with like combined with arithmetic like Python functions kind of thing. And so for example, if we do x plus 5, so x, our original variable here, plus 5, it's going to literally add 5 to every single element inside of the original array. So this is our original array here, x, and if we add 5 to this 0 here, we get 5. If we add 5 to 1, 6, 5 to 2, 7, etc., etc. 5 plus 9 is 14 there. So that's like how you use the ufuncs here, or the ufunctions. You could do something like x minus 5 even. And that gives you, that gives you the negative. Not the negative, sorry, but the subtraction. So 0 minus 5, 1 minus 5, 2 minus 5, etc. So pretty self-explanatory. Then you can do like the multiplication one too. That does the same thing, multiplies everything by the number 5. You can divide. So let's do divide by 2. That divides everything from the original array by 2. So 0 divided by 2 is 0. 0 divided by 1, 0.5, etc. What else could you do here? Let's see. So this is a whole section here. What did we just do? Oh, there it is. So that's what we just did here. That there. Set it as a -2 if you want. So you can see here there's also unitary functions for negation and all that. By the way, see if they have it here. There's, where's it at? Where's it at? Can't find it, but basically, definition for unitary function is they operate on a single input, whereas binary functions operate on 2 inputs. So binary obviously means 2. But anyway, in this case, the negation one, literally just put a negative sign there in front of the variable x. That gives you the negative value or whatever. You could do what's called the exponentiation u-func there, which just basically raises it to the power of 2 in this case. Gives you the output for that. And then the modulus one too, you got a u-func for that. So the same thing, just a percentage sign, and that gives you the remainder of the when you divide to the values. So in this case, x module 2. So our x is 0 here divided by 2, 0. That gives us 0. And the 1 there divided by 2 gives us a remainder. So in that case, since we got the remainder, we put a 1. 2 divided by 2 gives us no remainder because it's self-divides or whatever. So 0 there, and etc. What else can you do? Oh yeah, so it's pretty neat to see here. Each arithmetic operation also is conveniently like the wrappers basically to the like the Python functions, for example. So the plus sign here is just a wrapper for the actual add function. So np.add x2. So this is just going to add every. You don't need to know that actually for this section. I don't want to confuse anyone even more. But basically, these are the different wrappers in u-funcs or whatever for the different arithmetic functions. What they do here. So add, subtract, negative, multiply, divide, and so on. We could also do. There's a u-function for like arithmetic values or absolute values. Sorry. So let's do np.adds. Oh wait, it would probably be easier if we had an example with a negative here. So equals x minus x. And that's no z there. And then abs. So this function here, abs, the u function for absolute value, gives the absolute value. Basically the negative version of our original, or the opposite version of our original array. So the absolute value of -1 is 1, and so on and so forth. That's another thing you could do there. There's trigonometric functions you could do too, and these are pretty self-explanatory. So like p dot tan x, and that gives us that, and p dot cosine. And I'm trying to make this one a little, like this video quicker, just because if I were to go over every single thing, it would have been so long and boring to everyone. So yeah, you could also do the reciprocal of the trig function, so arc, and then sign. Not available in this case because yeah, you don't need to go on the math for that, but that's how you do that if you wanted to. So another common type of so all those were different. All these, by the way, that we've been doing were different u-funcs. So for arithmetic things. But there's also like u-funcs for exponentials. And that's how you do this here. If you want to take a look at that in the book. Again, I don't want to bore you with everything in here because it's so much. You can do it for the logs too. So log x, you can use log 2 base of something, in this case of x, or log 10 base. What else is pretty cool here? You can specify the output. So, for example, let's set that equal to x. Y equals and then we'll do, what is it again? Oh yeah, the out thing. np dot, let's do add, and then Just to multiply. And then you want to do x times 10, let's say, and then our out equals y. And there we go. So what we did here with this out, we're going to be looking at this specifically. Basically, we started by creating a variable x, which is the list of 0 to like 5 different values from 0 to 5, but not including 5. So 0, 1, 2, 3, 4. In this case, we created an empty array called y of 5 values as well. So empty just created an empty array with literally like nothing there for now. And then what we did was we wanted to use the function of multiply here. So everything gets multiplied inside of this original variable x by 10. That's what we specified here in the second parameter. And so you can see here like 0 times, obviously 0 there. And then 1 times 10 is 10, 2 times 10 is 20, etc. But anyway, we wanted to save this here as the out for y. So yeah, there you go. So basically it's so you can specify where exactly you want the result of a function to be saved at. Like if that makes sense. Just makes it so that you specify where exactly you want it to go when you get that result. You could use the reduce function here as well. So let's do this. np.arrange, so the same one they used. We'll set that equal to that. And then if you do x.add.reduce, oops. So what we did here, we set x equal to like we set a new array for x. So 1 to 6. So if we see 1, 2, 3, 4, 5. So we didn't include the actual 6, and we wanted to start at 1. And that's how we got this. And then we wanted to add everything inside that original 1 through 6 array. But like in this case here, in this line of code, we reduced it to one single output. So 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5 is 15. That's why we get this one single output of 15. So like if we were to do it dot multiply, dot reduce, and then x, we get 120. So 1 times 2 is 2, 2 times 3 is 6, 24, and etc. And that's how you do that. And also, what can you do? Oh, accumulate. It's pretty cool too. So np.add.accumulate. And that basically does the same thing as not essentially the same thing. Mathematically, it does the same thing as the reduce thing, except it gives you, it saves every output you would get. Instead of getting one single output, you get every output added onto the array. So 1 plus 2 is 3, that's this. Then 3 plus 3 is 6, that's this. 6 plus 4 is 10, and then 10 plus 5 is 15. So the same thing mathematically, but the output gives you something different. You get a single output with reduce, and the accumulation of the outputs with accumulate. And that's really it for that section there. I hope that made a little bit of sense at least. Because, yeah, I know how confusing that sounded. But, yeah, thanks.